Hello friends, today we are here to discuss one of the most important part of water chapter, and water chapter is there almost every syllabus of different universities. And what I found that student always struggling to do or to solve the numericals on the EDTA. EDTA, we know what is EDTA. EDTA is ethylene diamine tetraacetic acid. So this is one of the application of the coordination compound. Now this EDTA numerical, before I go and solve the real problem, I would like to say that this EDTA problem have two parts. One is the theory and then numerical. So first let us understand the theoretical part very quickly on the EDTA. How the EDTA help to measure the hardness of the water. Now we know the hardness of the water are of two types, permanent hardness and temporary hardness. So with the help of this EDTA titration method, we can measure the permanent hardness as well as the temporary hardness. Here I would like to mention for all my students that the temporary hardness can be removed by simple boiling. It means if I am titrating the boiled water, it means I am only measuring the permanent hardness, because by boiling we have already removed the temporary hardness. Okay, so let me start the theory of this EDTA numerical. But one more thing we need to remember, that theory is equally important, because we have found that the question may come of the theory of the EDTA as well as from the numerical of the EDTA. So we are going to discuss both the things quickly, but we will give more emphasis, more importance on the numerical part. Theory, just have an idea. So what happened in the EDTA numerical? Let me tell you. So first of all, we are taking a beaker, and here we are taking the hard water sample. We are taking the hard water sample, and which contains the calcium ion or the magnesium ion, because calcium and magnesium salts are the major contributor for the hardness of the water. Now what happened after taking the hard water sample? Then we are adding a buffer solution, the buffer solution of pH 10. Now the moment I write pH 10, you have to understand that we are talking about the basic buffer. Now sometimes we have noticed the question being asked that how we are making this pH 10 buffer solution. pH 10 buffer solution is a combination of ammonium chloride and ammonium hydroxide, because we know very well that how to make the buffer solution. To make the basic buffer, we have to take weak base and its salt. You can see weak base and its salt. Anyway, so this is a buffer that we are adding. Now question is coming, sir, why? Why we are adding the buffer solution on the hard water? We are adding the buffer solution in the hard water to maintain the pH 10. Then the next question coming, why to maintain pH 10? We are maintaining pH 10 because the moment I am adding EBT, which is an indicator. Okay, the EBT, the full form of EBT is Eriochrome black tea. The moment I am adding EBT, EBT should react with the calcium and magnesium. That is our desire, and that is only possible if we maintain the pH 10. So the conclusion is that we are adding the buffer solution to maintain the pH 10, because at pH 10 only the calcium and magnesium going to react with the EBT. So let me write this reaction. Let's say I am taking M plus N, okay, where it may be the calcium or magnesium ion. Now this metal ion react with the EBT and forming metal EBT complex. Okay, this is forming metal EBT complex, and this metal EBT complex showing the wine red color. So let me write wine red color. Okay, so this is wine red color of the metal EBT complex. So we understood this. So what we have so far here also so far we have the wine red color of this mixture. Now we are going to titrate. Okay, we are going to titrate with the EDTA solution. Okay, we are going to titrate with the EDTA solution. Okay, we are going to titrate with the EDTA solution from here. Now EDTA, as I told you, EDTA is ethylene diamine tetraacetate acid. Now this one is a hexadentate ligand, having hexadentate ligand, so it have a 6 donor center. So hexadentate ligand, and now you understand that EDTA is a strong ligand. So what will happen, that EDTA will react with this metal EBT. So I can directly showing here that, or else I can write one more equation. Okay, I write in a different way also, like if I write A metal EBT complex react with the EDTA. Okay, react with the EDTA, and what is happening, that metal EBT complex is forming, metal EDTA complex is forming. Okay, metal EDTA complex is forming and EBT become free. Okay, EBT become free. Now this free EBT showing the blue color. Okay, the free EBT showing the blue color. So you can see the color change. You can see the color change in the entire titration, that wine red to blue. So this is the process. This is the process of doing the titration. So this is the theoretical part of the EDTA. So let me summarize very quickly. Okay, and in every case we are going to take the volume of the EDTA. Okay, when we take the normal sample, normal hard water, you can calculate the permanent total hardness. The moment I boil the water sample, I will get the permanent hardness, and by subtracting the permanent hardness from the total hardness, we can get the temporary hardness. I am going to show you very quick and easiest way, so that all my students can do it better way and get the maximum number. So this is the theoretical part of the numerical on EDTA. Like we understand that we are taking the sample. The sample, as I said, sample can be changed. You can take the normal hard water to calculate the total hardness. If you take the boil hard water, you will get the permanent hardness. So, and the process remains same. So water sample, then you have to add again the buffer solution to maintain the pH 10, then EBT, the solution color become wine red. We are titrating with the EDTA. EDTA is a strong ligand, and color change from wine red to blue. That is my end point. So by this way, we can find out the amount of EDTA required for the titration. So this is all about the theory. Now we are going to tell you the steps by steps. Okay, we will follow simple 5 steps, only 5 steps, simple 5 steps to find out all the results, and it will be very helpful for the student to do the numerical. So what I'll do, we are going to discuss the different steps involved in the numerical. Okay, now we are, as I said, that we are going to follow 5 simple steps to do the numerical of EDTA. And the moment you understood the thing, then the all kind of numerical will be EDTA numerical find very easy. Okay, so what is the first step? The first step is to know the strength of standard hard water. Okay, to know the strength of the standard hard water in milligram per ml. So that is the first thing. And remember, all the values will be there in the numerical. Only the values may change to numerical, that is not a problem, but this information will be there in the numerical. So strength of the standard hard water in milligram per ml. If it is there, it is fine. If it is not there, we have to do it like that, milligram per ml. Okay, so second one, suppose if I take one example, that 5 gram of standard hard water or else I can write 5 gram of CaCO3 is dissolved in 500 ml. So this kind of stuff suppose given 5 gram of calcium carbonate is dissolved in 500 ml. So what to do it? So we know that 500 ml of standard hard water. Now question is coming, sir, why you are saying this is a standard hard water? Okay, why they are saying this is a standard hard water? Because you can see we know that how much calcium carbonate is present in the water. That is the reason they known as standard hard water. So 500 ml of standard hard water contains 5 gram of CaCO3. So can I write that 500 ml of standard hard water contains 5 into 10 to the power 3 milligram of CaCO3, because you can see I have to convert in milligram. So 1 ml of standard hot water contains 5 into 10 to the power 3 divided by 5 into 10 to the power 2, because 500 means 5 into 10 to the power 2. So equals to, you can see this will come something like 10 milligram per ml. So this is what I would like to say. This is what I have to do in the first step, strength of standard hard water. If in the numerical it is given like 1 milligram present in 1 ml, then no need to do anything. If it is not given, then only we have to follow this kind of step, that how much milligram of calcium carbonate is present per ml of standard hard water. Okay, now we go for the second one. Now after the step 1, we go for the step 2. Now step 2 is the standardization. Standardization of EDTA. Standardization of EDTA. That is very, very crucial. Okay, now why we are doing this step? Because according to the rule that we have to convert all the hardness into calcium carbonate equivalent. That is the reason we are doing it. So the standardization of EDTA, how we are going to do it? It means standardization of EDTA means 1 ml of EDTA means how much milligram of calcium carbonate. 1 ml of EDTA equals to how much milligram of calcium carbonate. That is exactly our motto. Now consider if I write like 50 ml of standard hard water required 30 ml of EDTA. So suppose this exactly this kind of statement will be there in the numerical. As I said, in every line you will find some of the information are given. First line talks about the standard hard water. Second line talks about the standardization of EDTA. So 50 ml of standard hard water required 30 ml of EDTA. As an example we are taking. So can I write that 30 ml of EDTA is equivalent to 50 ml of standard hard water. Now 50 ml of standard hard water. Now I consider that in 1 ml, okay, consider let's say or else let me write, suppose 1 ml of standard hard water contains 1 milligram of CaCO3. So as I said, this is I'm just as it taking 1 ml, like the example I have shown you there, I have shown that 1 ml of contains 10 milligram. So here also I'm just taking for the simplicity. Okay, we'll take the real example after this. Suppose 1 ml of standard hot water contains 1 milligram of CaCO3. So I'll write that 30 ml of EDTA is equivalent to 50 ml of standard means 50 milligram of CaCO3, because you can see 1 ml contains 1 milligram. So 50 ml contains 50 milligram of CO3. So 1 ml of EDTA is equals to 50 by 30 milligram of CaCO3. This is exactly we want. As simple as that. This is done. So the standardization of EDTA is done the moment we understood that 1 ml of EDTA equals to how much milligram of calcium carbonate. So we are done with the step 2. You can see, so simple. Okay, very simple. So only once we understand the thing better way, and I hope my video will help you. No matter how much you understood before this, but after this, listening to this video, I am very sure that you will be in a position to do it better, to deliver it better. Okay, so 1 ml of EDTA equals to 50 by 30 milligram of calcium carbonate. So now we go for the step number 3, that is the calculation of the total hardness. Now we are going to discuss the third point, okay, which is related to the answer of the numerical. Okay, that is the calculation of the total hardness. So calculation of the total hardness, very simple. It is given that how much normal hard water is required for the EDTA titration. Okay, or how much, as I said, how much EDTA is required for the titration of the normal hard water. Okay, from there we can calculate the total hardness. Okay, and then you find in the numerical must be given that the same sample after boiling, how much EDTA is needed. So the moment they are talking about the sample boiled water, it means they are talking about the calculation of the permanent hardness. They are talking about the permanent hardness. Okay, now point number 5, if I say, what is the point number 5? The moment I have to calculate the temporary hardness, we know the temporary hardness is the total hardness minus permanent hardness. Okay, the total hardness minus permanent hardness will give you the temporary hardness. So in any kind of numerical, they are going to ask you two things. Either they can ask that calculate the total hardness and permanent hardness and temporary hardness in the name of various hardness, or else they can only ask you to calculate the temporary hardness. But the process exactly remains same. So what are the steps? Let me quickly recap, so that we can go for the numerical after this, so that we can easily do it. The first one is the knowing the strength of the standard hard water in milligram per ml. Number 1. Number 2, standardization of EDTA. Number 3, calculation of total hardness. Number 4, calculation of the permanent hardness with the boiled water. And if I subtract the permanent hardness from the total hardness, you will get the temporary hardness. As simple as that. So by knowing this theory, by understanding this concept, now we'll go for the couple of numericals, and I hope it will give you a very good idea and better understanding to answer any kind of numerical in the EDTA. Okay, so now after discussing the theory part, the steps required or the steps involved to solve this kind of numerical, so we are landed at the last part of this discussion, and that is to take a real example, take a real numerical. Mind you, the similar kind of wording you will find almost in all the numerical. The wording remains same, only the change in the values. Everything remains same. Okay, so let's quickly do it. A standard hard water contains 15 gram per liter calcium carbonate. So this is a standard hard water because we know how much calcium carbonate is present. 20 ml of this water require 25 ml of EDTA solution. So this line indicates the standardization of EDTA, how we can calculate, and you can see 100 ml of sample water. Sample water is the normal hard water. So from this value we can calculate the total hardness, and you must have seen the same solution after boiling. It means the same solution means 100 ml solution. The moment we are boiling, it means we are removing the temporary hardness. Okay, require 12 ml of EDTA. And calculate the temporary hardness. We know the temporary hardness. What is temporary hardness? That temporary hardness we can calculate. Temporary hardness is the total hardness minus permanent hardness. Total hardness minus permanent hardness, we know that. So we have to calculate the total hardness, we have to calculate the permanent hardness. So in order to do that, let's start from the beginning. The step number 1. The step number 1, I told you that strength of the standard hard water. So what is there? 15 gram per liter. So can I say, okay, so let me write in step number 1 that 1 liter of standard hard water, okay, contains 15 gram, or can I say 15 into 10 to the power 3 milligram of CO3. I can do that because I told you we have to find out the amount of calcium carbonate present in milligram per ml. So 1 liter means 1000 ml of standard hard water contains, let's say, 15 into 10 to the power 3 milligram of CO3. So 1 ml of standard hard water contains how much? 15 into 10 to the power 3 divided by 10 to the power 3, because 1000 means 10 to the power 3 is equals to 15 milligram of CO3. So we are done with the first step. So I am just making it a block so that all my students can understand this is the first step that we are done. So 1 ml of standard hard water, we are done. Now we have to go for the next one, and that is the EDTA. Okay, EDTA, how we are going to do it. Okay, so now after knowing that, we can just write that 1 ml of standard hard water is equals to, let me write, 15 milligram of CO3. We understood this. This is the first line that we got from the step number 1. Now we go for the step number 2, and that is the standardization of EDTA. You can see what they have said. 20 ml of this water means standard hard water, require 25 ml of EDTA. So can I write 25 ml of EDTA is required, or I can just write required 20 ml of standard hard water. So exactly the same thing I have written what is there in the question paper. So that will help you to write also. Now here let me tell you a small tricks. Whenever you calculate the 1 ml of EDTA, keep in mind that we have to write the EDTA from left to right. Don't write from the right to left. It seems that EDTA, this sentence need to be, EDTA should be left hand side of the equation. Like 20 ml of EDTA required. We are not going to write 20 ml of standard hard water required 25 ml of EDTA. Then it will be difficult for you. So better you write that 25 ml of EDTA required 20 ml of standard. So EDTA on the left hand and standard hard water on the right hand. So it will help you to calculation a bit further, or the calculation make easy. So so can I write that 25 ml of EDTA required 20 ml. So 1 ml equals to 15 milligrams. So 20 ml means 20 into 15 milligram of CO3. Okay. So 1 ml of EDTA equals to 20 into 15 by 25 equals to 12 milligram of CO3. So this is the standardization of EDTA. Okay, this is the standardization of EDTA. See how simply we can do it. Okay, by simple following one simple step, we can easily find out that 1 ml of EDTA equals to how much milligram of calcium carbonate. Now we go for the step number 3, and that is the main thing. You have to calculate the total hardness. 100 ml of sample water required 18 ml of EDTA. So what I'll write? I'll write 100 ml of let's say normal hard water, okay, required 18 ml of EDTA. So can I write that 100 ml of normal hard water require 18 into 12 milligram of CaCO3. Now why I did it? Because I have to I already told you that we want the hardness in milligram per liter of calcium carbonate. Okay, how much calcium carbonate equivalent we need to do. So you can see 1 ml of EDTA, it means 12 milligram of calcium carbonate. So 18 ml means 18 into 12 milligram of calcium carbonate. So 100 ml contains this much. Then 1 ml contains how much? 18 into 12 by 100 milligram of CaCO3. Okay, now if I write 1000, because 1000, why I wrote 1000? Here is a question, because 1000 is required, because what is our unit of the hardness is milligram per liter. Now milligram per liter, 1 liter means 1000 ml. That is the reason we have calculated in 1000. So 1000 ml of hard water contains 18 into 12 by 100 into 1000 is equals to 2160 milligram per liter. So this is our, so the total hardness. So we got the first answer here. The total hardness is 2160 milligram per liter. Okay, 21. Okay, so now after the calculation of total hardness, so how much we got? We got the total hardness is 2160 milligram per liter, or you can say 2160 ppm. So that is our first requirement. 2160 ppm is the total hardness, because we took the normal hard water. Now come here. So we are done up to this. So we are done with this. We are done with this one. We are done with this one. Now we go for the same sample after boiling. So this is where now we are targeting boiling. After boiling means obviously we are going to talk about the permanent hardness, because by boiling you are removing the temporary. So only boiling hardness, only the permanent hardness is remaining, and that is the reason you can see less amount of EDTA is required for the titration. So can I write that 100 ml of boiled hard water required 12 ml of EDTA. So very simple, 100 ml of boiled hard water required 12 into 12 milligram of CaCO3. Why? Because I already told you that 1 ml of EDTA, 1 ml of EDTA is equals to 12 milligram of CaCO3. We already discussed that. Now for 1 ml obviously require less, so 12 into 12 by 100 milligram of CaCO3. Okay, milligram per ml of CaCO3. Now for 1000 ml, now 1000 ml, similarly obviously 12 into 12 into 1000 divided by 100, it equals to 1440 milligram per liter, because the moment you are multiplying by 1000 ml, it is become liter. So now here you can see how I got the presence of total permanent hardness. This is will give you the permanent hardness. So but they have asked in the numerical, if you say they are asking for the temporary hardness. So the answer for this, okay, so I can write the answer. Now that we got the total hardness, we got the permanent hardness. Now if I subtract the permanent hardness from the total hardness, we will get the temporary hardness. So temporary hardness is equals to total hardness is 2160. Now the permanent hardness is 1440 ppm. Okay, so we are getting 720 ppm is my ultimate answer. Okay, so this is how we are going to do the numerical. I hope it is helpful. I am going to give you more videos on the all other different numerical of this water chapter. Thank you very much.